So welcome everybody. My name is Laurie with the Iceland School of Energy, and welcome back to another episode of Alumni in the Industry. For those of you who haven't been on a call before, this is a platform where we bring back alumni who are currently out doing cool things and then bring them back to talk to current students, prospective students, and other alumni who just want to, stay connected. Today we have with us Caroline Medino, or Caroline Clark. Congratulations.
Thank you.
So I'm not going to do a big introduction, but Caroline will do that. But basically the format of today's talk, Caroline's got a presentation for us, and then there'll just be an open Q&A afterwards for as long as it stays active. So Caroline, the floor is yours.
All right. Thanks, Laurie. Thanks everybody for coming. Really excited to talk to you guys about what I do in my job and at Covanta, and also happy I probably messed up on that pronunciation, but hope you are enjoying your buns. So as Laurie said, my name is Caroline Clark. Well, most of you know me as Caroline Medino, and currently I am an environmental engineer with a focus in compliance at Covanta. So I'm excited to teach to you about waste to energy and how it fits into the waste management industry. All right. So here's a brief agenda, an introduction of myself, followed by waste to energy and how it's sustainable, an overview of Covanta, my company, and then my specific role at the company. And then we'll go to the questions and answer section. All righty. Let's see. Okay, so before making my way to Iceland, I grew up in northern New Jersey in the United States. So that's in the northeastern part of the country. So I was about 45 minutes from New York City from Manhattan, but that's only if you leave at like 3 in the morning and there's no traffic. Granted, right now there's not really as much traffic because of COVID, but I grew up in Pompton Lakes. It was a typical suburban U.S. town. For my undergraduate, I went to Worcester Polytechnic Institute, and I studied, so that's in Massachusetts. Can you put my laser pointer? So it's about 3.5 hours from where I grew up. And I studied chemical engineering. And here's a picture of the school. And most of my time spent outside of the classroom was playing softball. So just wanted to include that picture as well. And I was interested in renewable energy. I took a few courses in my undergrad, and I was fortunate enough to go on the green program for in my senior year during my winter break. And I fell in love with the country. I loved the program, and I really wanted to pursue sustainability. So I graduated in the spring of 2017 and then went over to Iceland in the summer. So while in Iceland, I studied sustainable energy engineering. I took a bunch of different courses. I was interested in wind and hydropower, but I wanted to kind of take a bunch of different courses. I was fortunate enough to have an internship with Landsvirkjun in the spring of my first year. So we looked at wind energy and microgrid feasibility in remote areas of Iceland. I also was fortunate to write a paper with Renata on using wind as reserve power through our smart grids course. And I presented it at a conference in Riga, Latvia. So you can see in the top right picture. So I just included a few different pictures of a few of my favorite things while in Iceland. I'm very grateful for the friendships and the ability to travel so much, and because Iceland's a very good location to be able to travel to a bunch of different areas as well as do sightseeing within the country. For my thesis, I worked on improving current efficiency in low temperature aluminum electrolysis with vertical inert electrodes. So kind of jargony, but basically looking at aluminum smelting and making it more sustainable by changing the materials. So I have a video. Let's see if this works and plays. 1 second, let me turn the laser off. The volume's not really needed. So this is just from one of our experiments after we made the aluminum, taking the anodes and cathodes out of the system. So you can see there's molten aluminum on that middle one. And then I just also included a picture of our product. So this is a little nugget of aluminum. Okay. So fortunately, while I was working on my thesis, I landed a job at Covanta, and it's very convenient that the location, the corporate headquarters where I'm at, it was about 25 minutes from where I grew up. So since the summer of 2019, I've been at Covanta. We're a sustainable waste management company, and we provide sustainable waste and energy solutions to our clients to ensure no waste is ever wasted. So what does that mean? There's always some value within a product at the end of its lifetime. So we want to make sure that it's utilized to its fullest potential. We have helped clients minimize their environmental footprint and maximize their value. Our clients range from residential areas, commercial, so working with different companies as well as federally, working with the government, so to help them reach their sustainability goals. So our core business is our waste to energy facilities. We also use the term energy from waste, so I might use them interchangeably throughout the presentation. We have a subsidiary business called Covanta Environmental Solutions. Is there anything? Oh, sorry, Lori. No, my camera's okay. Surprisingly, the light hasn't gone out yet. Yeah, so we have a subsidiary business, Covanta Environmental Solutions, that provides other environmental services. And I don't have too many pictures in the field, unfortunately, but you can see this is our Lancaster facility in Pennsylvania. So I was standing here on the roof. You can see the stack behind me, so I was doing some observations of our stack. Okay, so now you might be asking, what is waste to energy? So to put it simply, it's a process where non-hazardous post-recycled material is combusted to recover both the metals and the energy. So during combustion, heat is generated, and the heat from this is recovered in the form of water, which is then heated in the steam in our boiler tubes. So then this steam goes to spin a turbine-driven generator to create electricity. The metals are recovered from our ash residue, and then they're recycled where all the gases are collected and filtered and cleaned before being released to the atmosphere. So we generate electricity, we recover metals, and we make sure that we collect, filter, and clean the flue gases before releasing them. So here, this video is a virtual tour of our Durham York facility in Ontario. Let me play this. Sorry about that, 1 second. Okay.
We're Covanta, a world leader in providing sustainable waste and energy solutions to municipalities, businesses, and industries. If you've ever wondered what goes on behind the scenes at one of our energy from waste facilities, we'd love to show you. We're proud of our modern plants and the people who work here. So come on in. Once trucks arrive, they are weighed and checked in before heading inside to the tipping hall. The waste is unloaded onto the tipping floor and visually inspected for any unacceptable items, which are removed for separate recycling or proper disposal. Waste is then pushed into a storage pit and thoroughly mixed before being loaded into bins, which we call hoppers, where it travels to the combustion chamber. The tipping and waste storage areas are maintained under negative air pressure to contain dust and odors. Once fed into the combustion chamber, waste is combusted at extremely high temperatures in a self-sustaining process at approximately 2,000 degrees Fahrenheit. A typical hopper load is completely combusted in 1 to 2 hours. As waste is burned, the heat converts water in the steel tube-lined walls into steam that rises through boiler tubes where it is superheated. The steam turns a turbine-driven generator to produce electricity, or may sometimes be used directly for heating or industrial processes. The electricity produced by the turbine generator is exported to local utilities for use in homes and businesses. Each ton of waste can generate 550 to 700 kilowatt hours of electricity. Steam from the process is condensed back into water and returned to the boiler tubes, making it an efficient, closed-loop system. After combustion, the volume of waste is reduced by 90%, leaving an inert ash and metal. Remaining ash is beneficially reused or landfilled as non-hazardous waste. Ferrous metals such as iron and steel are recovered using a rotating drum magnet, and non-ferrous metals like aluminum and copper are separated by an eddy current system. Collected metal is sold to be made into new products. State-of-the-art air pollution control equipment ensures that emissions are well below limits to be fully protective of human health and the environment. We neutralize acid gases using lime in a scrubber reactor and inject activated carbon for heavy metal control. We control emissions of particulate matter primarily through a bag house, which employs thousands of fabric filter bags. All flue gas must pass through the bags before exiting through the stack. Throughout this process, the control room closely monitors emissions through a real-time continuous emission monitoring system, controls steam flow, and a number of other automated systems inside the facility. Covanta is committed to providing sustainable waste and energy solutions to ensure no waste is ever wasted. At Covanta, we believe the materials discarded every day should be utilized to their fullest potential to preserve the world's valuable resources and generate clean energy for our communities and the world we live in. This is how Covanta is powering today and protecting tomorrow.
All right, so that's it. That's the end of the presentation. No, I'm just kidding. But the video was a little bit long, but I thought it was a very good overview of what we do at Covanta. So now you may be thinking, where does the energy recovery fit in the waste management? So both the US EPA and the EU have a designated waste hierarchy, which displays the materials management. So you can see that they're placed in order of descending environmental impact. So of course, preventing, so not even creating the waste in the first place, has the smallest impact on our environment. And this is followed by reducing, reusing, recycling, and composting. Energy recovery is then the next most preferable option after this recycling, with the largest impacts on the environment from landfilling. So I wanted to stress that in order to get the maximum greenhouse gas benefit / reduce our impact on the environment, waste should be managed according to this hierarchy from top to bottom. So now that we know the best ways to manage our waste, how do different countries throughout the world compare? So as you can see, the US is not doing a very good job at their waste management, where we landfill nearly 2/3 of our waste. We're recycling about 30%, and then energy from waste is about 7%. So this is quite different from Europe, where they have enacted sustainable waste management policies, rules, and regulations for how to manage their waste. And you can see on the screen that Denmark and Germany are leading Europe with Denmark's nearly 50%, Germany's over 50% recycling, and then the next is energy from waste, and you can see there's very little landfilling. So instead, they use energy recovery to extract the value out of the materials that they can't recycle rather than doing landfilling. And then I also wanted to include Canada, because Canada is very similar to the US, and where there's a lot of land. So you can see there's a similar breakdown with over 2/3 landfilling. And then I also included Iceland, since obviously Reykjavik University is in Iceland and we've all lived there. And you might be surprised to see that it has a similar ratio with almost 2/3 landfilling as well. It is interesting to note that 4% of the trash utilizes energy from waste, and this is because in 2019, Iceland started sending their trash to the Netherlands, so about 70,000 tons a year are now using the waste to energy system. And then I also included the United Kingdom. Covanta is starting to build a few facilities in the United Kingdom, and they're stressing improving their waste management. So you can see that they do recycle a decent amount, and the energy from waste is starting to slowly increase. So we all know that reducing, reusing, recycling helps to minimize our environmental impact. But you might be asking, why waste energy? Why utilize this compared to landfilling? Why is it better environmentally? So first, using energy from waste instead of landfilling eliminates the production of methane. And methane is 84 times more potent than CO2 over a 20-year period. So this is obviously particularly important given the current global push for combating climate change in a timely manner. Also, there is leachate generated from the trash in the landfill. So basically, heavy metals can go through the water and get into the groundwater and contaminate it. It's not a very sustainable use of land, as it requires a lot of land. And energy generation from the landfills is about 65 kilowatt hours per ton of waste. So energy from waste facilities are able to recover much more energy than landfills, and even those equipped with gas collection and energy recovery systems. So it's about 9 times as much energy per ton of waste on average. And just a statistic, the US landfills only capture about 50 to 70% of the landfill gas generated, so there's still a lot of methane being emitted into the air. Energy from waste utilizes a 90% reduction of waste in volume. So even if the ash from the process could potentially go into a landfill afterwards, the volume is a lot less than it would be for the trash from a regular landfill. We also provide clean baseload power generation, and this can be very complementary to the current renewables because they're intermittent, because the sun's not always shining and the wind's not always blowing. So it can be a very good complement to the other renewable resources. Energy from we also recover metals for recycling. There's about 50 pounds of metal per 1 ton of waste. So this is about 2 to 3% of the waste coming into our facility is metal. And by utilizing our different metal recovery systems, we can recover a lot of metal. It's about 500,000 tons of metal a year, which if you're landfilling, that metal would simply be buried. So, and that's pretty much it for this one. So that's the case for waste energy. And then more benefits is that it actually is a net negative greenhouse gas emissions when you're looking at every ton of CO2 equivalent per ton of MSW diverted from the landfill. So if by using energy from waste, we're saving a ton of CO2 equivalents from a life cycle approach. So how is this possible? So you can see, in order to recover energy, we have to combust the waste, and the combustion process emits CO2. However, we are reducing greenhouse gas emissions by avoiding the alternatives of landfill, avoiding the methane, so, as well as we're providing baseload power that could have otherwise been generated from fossil fuels. So if we look at this chart, you can see the first one is CO2 from just combustion of municipal solid waste. This first green chart is showing CO2 from combustion of biomass, and it's not counted as an emission because this carbon, if you were to put this material in the landfill, it would anaerobically break down and decompose anyway. So it's already a part of the carbon cycle. So it's not counted as an emission because it would already be being generated. And then the second blue bar is CO2 from combustion of plastics as an emission. So for example, plastics, rubbers that are created by using fossil fuels, it's what this is counting for, the emissions. Okay. And then this next one you can see is CO2 avoided by steam and electricity generation. So that's what I was saying before, in the fact that by providing electricity from waste to energy facilities, that's replacing, for example, coal-fired plants. Okay. The next one is metals recovered for recycling. So by recovering metals in our process, we don't have to create new virgin metals from a process, which in most cases in the US utilizes fossil fuels as the energy source. So it takes a lot less energy to recycle and reuse the metal than to create it in the first place. And then the fourth bar and the largest bar represents, like I said, methane emissions that are avoided by utilizing energy from waste. So we're diverting the waste out of the landfill. So even when you consider that landfill gas collection, because landfill gas can be utilized as an energy source as well, it still has a huge impact, and that landfills are the third largest sources of methane on the planet. So this chart is just reflective of the US breakdown. So about 44% of the waste managed in landfills utilize gas to energy systems, 38% use flare, and then there's 18% of landfills that have no gas controls in place. So that's what this bar is representing. So then combining the two blue shaded bars cancel each other out, and then you can see that the metals combines with the methane avoided by EFWs, which gives you a net greenhouse gas of about saving a ton of CO2 per ton of MSW combusted. So energy from waste is actually the only major source of electrical generation that is net carbon negative. So in this chart, you can see that the life cycle greenhouse gas emissions, so you can see it on the left-hand chart, is in tons of CO2 equivalents per megawatt hour generated. So you can see obviously coal and natural gas are quite high, but energy from waste has a negative net carbon reduction because of it both manages waste and at the same time generates electricity and prevents the methane emissions from the landfills. And then mostly the wind and solar, most of their life cycle greenhouse gas emissions are due to upstream. So for example, mining the rare earth metals in order to create the solar panels. So lastly, energy from waste can be beneficial in that it utilizes less land. On average, energy from waste facilities need less than an acre per megawatt hour. So in contrast to landfills are about 27 acres per megawatt, solar requires 8 and wind is 18. So I know most of you are not in the US, you're like, what the heck's an acre? So I also put it in meters squared and kilometers squared. And then just for reference, I have for Klambratun is about 30 acres. So that's about the size of a landfill. And then a football field is about 1.76 acres. So less than half of a football field is required for land use for energy from waste facilities. So now we've got an introduction to waste energy, and now I'm gonna talk to you about Covanta. So Covanta is a world leader in waste to energy, operating over 40 facilities in North America and Europe. We make up about 70% of the US market, and annually we process about 21 million tons of waste. And the waste is processed generating 10 million megawatt hours, which is enough to power over 1 million homes. Through our metals recovery, we recycle, before I said 500, I meant it's been increasing over the last few years. So now we are recycling over 600,000 tons of metal, and that's equivalent to about 6 Golden Gate bridges. We provide employment to nearly 4,000 people in North America, and we have our high focus on sustainability and encouraging a circular economy. Before in the beginning, I mentioned that we have a subsidiary business called Covanta Environmental Solutions, and it helps more than 3,500 customers across North America identify opportunities to minimize their waste and find beneficial reuse for their materials that would otherwise be thrown away. So for example, in the bullets you can see we help with total waste and materials management. We help with liquid waste management. So for example, we can treat wastewater to be beneficially reused. We have this plastic and packaging good depackaging, so we call it unwrap, so we can work with our commercial customers. For example, if someone in consumer healthcare had something that expired, we can depackage that product and either reuse or recycle it and get rid of the expired contaminant. We also help with universal waste, electronic waste recycling, product destructions. We have a drug take-back program that we work with the U.S. Drug Enforcement Agency to collect drugs and then safely destroy them rather than them getting into the hands of someone else or flushing them down the toilet. We take that product and we safely destroy it. So Covanta, although our primary business is waste to energy facilities, we are a sustainable waste management company and we offer other environmental services. I just wanted to give you an overview of our Covanta facilities in North America. You can see that we're concentrated a lot in the Northeast, and this is attractive because densely populated areas have limited access to alternative disposal like landfilling in more metropolitan areas. So they have to weigh the cost advantage versus long hauling the trash to landfills. So you see even like in Europe, since there's less land, it's more densely populated, that energy from waste facilities are advantageous because the trash isn't being transported that far and the energy is being recovered and for electricity generation and metals recycling. So this is our North America map. And then we have also started working in the United Kingdom, and as well as we have a facility in Ireland. So the UK is committing to more sustainable waste management by diverting their trash from landfills to energy recovery and recycling. So we're proud to be partnering with them as they go through this transition. So I just wanted to point out, so Dublin is already operational. They can take in 600,000 metric tons per year and produce up to 60 megawatts. And then I also pointed out our Rookery facility because in my role, I'm working with them as they're onboarding and getting their pre-compliance for pre-commissioning. And so just wanted to point that out. They should be up and running in the spring of this year, I believe about in May. So hopefully I'll get to go there at some point. Okay, so my role at Covanta, I focus on environmental compliance. So our right to operate waste energy facilities is directly linked to our environmental compliance. And our permits are based on environmental impact and potential emissions to the surrounding environment. So these permits vary across the country and the world, but they're based on environmental medias. So for example, in the US, we have what's called a Title V air permit. We have solid waste permits, stormwater, wastewater. A lot of European countries have multimedia permits. So that's nice that it's all encompassing in the one permit itself. So each facility must comply with these conditions and requirements stated within the permits. In my role, I help the facilities comply with them through our environmental management systems. These systems help our environmental specialists. So each facility has a designated environmental person noted as an environmental specialist or an environmental manager. So they're in charge of making sure that we're complying with our permits. So I help them manage these environmental systems, such as having to do monitoring. They might have monitoring requirements, sampling requirements, reporting requirements, And our environmental management information system, or we call it EMIS, allows us to track timely completion of these compliance requirements and manage associated compliance data. A major portion of my role has been taking the information from these environmental management systems and bringing them into a user-friendly reporting platform that can be accessed fleet-wide. So our EMIS systems are accessed and managed by our specialists. So I'm taking the data and information from that system and putting it in a report so that someone in corporate, someone in a different region can access the data so they can analyze the information. We can make adjustments, view trends to continuously improve our environmental performance. Just for a quick example, one of my major projects last year that I worked on was integrating. Our specialists have to perform a weekly walk down, a weekly environmental walk down. So they have to walk down the plant and make sure that there's no areas of concern, and if there are, that they make note of them. So this used to be paper-based, so I helped to bring it electronically and allow for picture taking and tracking action items to remove any potentially unsatisfactory areas and to improve our performance and try to make it better. So our main compliance in general, our main focus areas are on air and ash. So I'll be going through that on the next few slides. In terms of air compliance, as you heard during the video, we have a bunch of control technologies in place. First, we have a sophisticated boiler design, so that ensures complete combustion of the waste. So it takes into consideration time, temperature, and turbulence. So we maximize our combustion in order to minimize, for example, incomplete combustion where carbon monoxide is generated. We also utilize selective non-catalytic reduction systems, or an SNCR, for NOx control. So it's injecting ammonia or urea into the furnace to convert the NOx into harmless nitrogen gas. We have activated carbon injection systems, which is added to the flue gas to allow, for example, mercury and dioxins to adsorb to the surface, and then they're removed downstream in our baghouse. We also have our scrubbers that neutralize any acid gases through a spray lime slurry system. So the acid gas reacts with the lime to form salts. They dry and leave a salt residue, which are then, again, removed downstream through our baghouse. So after all the treatment, the gas goes through this baghouse, which kind of acts like a vacuum cleaner with a filter bag traps. So it traps in particulate matter and then the lime and fly ash to the bag surface. And these bags are periodically cleaned to remove the ash and metals in the bottom of the baghouse. All the while, we have all these control technologies. We have a continuous emissions monitoring system. So it's continuously monitoring different pollutants such as CO2, SO2. So this is on a continuous basis. And then we also have annual stack testing. So in this, over 3,000 stack test analytes, so different pollutants, are monitored. So it kind of just sets the standards for our facility, and it makes sure that we're in compliance with our emissions limits. And then I just wanted to show you real quickly. We started a sustainability program, I believe, in 2017. And since then, you can see a reduction in our emissions. This is comparing 2017 to 2019 compared to 2007. So we've had a decent reduction in the different pollutants, as well as this bottom chart shows our emissions comparatively to the federal allowable standards. And then we also look for compliance at our ash generated from our facilities. So waste energy facilities generate ash residue as a byproduct when they combust the waste. So any non-combustible material in the waste and a small portion of the carbon and lime from the air pollution control form our ash. So you can see the bottom ash comes from the bottom of the boiler, from the grate. So after the trash is combusted, and then what we call fly ash is taken when the baghouse bags are cleaned off. So it's about 85% bottom ash and 15% fly ash. In Europe, they keep bottom ash and fly ash separate, whereas in the US, we combine bottom ash and fly ash to call it combined ash. And we have to actually characterize our ash on given frequencies. They vary across the state, but basically what we have to do is we have to test our ash and ensure that it's non-hazardous through a different testing procedure. So we have to simulate landfill leaching. So I like to compare it to kind of like coffee. So when you heat up the water, it trickles through the coffee grinds, and then you get your coffee obviously afterwards. So in this testing, we simulate what it would be like for 100 years at a landfill with our ash in it. So we have to verify that it's non-hazardous, and our ash is non-hazardous. We have about, I believe, 30 years of data showing. So, but some difficulties. Fly ash is hard to reuse because it contains chlorides and metals, and then bottom ash has potential reuse for aggregate in the construction industry. So Europe is doing that now. They take their bottom ash and further process it to utilize it in cement and construction. And there's no current use in place in the US due to lack of regulation. So this is a focus area for Covanta. So then, yeah, you can see on the chart on the right just where our ash goes in the US. So you can see most of it, we have ash monofills, as well as commingling with MSW, and then beneficially reusing it as landfill daily cover. So since it has this aggregate properties, it can harden and be used as cover for landfills. So I just also wanted to bring up our metals management, and we are currently doing a total ash processing system. So this falls in conjunction with the reuse of the bottom ash. This metal management facility is in Pennsylvania. And so energy from waste facilities send their ash to this system where it can be broken down into its component parts. So you can utilize aggregate for asphalt, for concrete. It further cleans the ferrous and non-ferrous metal, and then anything left over can be used residually in landfilling. So this process allows us to recover small metal fractions. We're even actually recovering some rare earth metals, which is really cool. And then it can also reduce the disposal of ash in landfills by up to 65%. So before I stated that taking the trash and combusting it reduces it 90% by volume. And then by putting it through this total ash processing system, it can even reduce by up to 65% from that 90% reduction. And then I just wanted to end the presentation with highlighting other areas that for like community engagement. So we strive to make a positive impact on the communities that we operate in. We have a bunch of community-based programs for each individual facility. They have their own program set up. So it's just showing that we aren't just a business, but we want to make a positive contribution to the areas that we operate in. And nearly 50% of our employees live within 10 miles of their facilities that they are employed in. So these are our backyards too, and we want to take care of our neighbors. So we do a bunch of different things like facility tours. You can see we have community cleanups, toy drives for Christmas. We help out with the food pantry, soup kitchen. We take marine debris out of the ocean. We work with a company called Fishing for Energy. So we help clean up and then take that debris and bring it to our waste energy facilities. And then we also have green education, STEM, retiring American flags properly, and other volunteering service. You can see we have Habitat for Humanity in the center of the page. So just really focusing in on that. We're operating in these communities, and we want to have a positive impact and play a positive role where we operate. And then, yep, that's the end of my presentation. Sorry, it's a little bit long, but there was a lot of information, and I just want to leave you with this, that environmental awareness and performance is the responsibility of every employee at Covanta, and that by embracing it, we can make a difference. So environmental awareness and sustainability is at the forefront of our business. It's every employee's responsibility. If we're not taking care of the environment and we're not being good neighbors, then we can have our right to operate be taken away. So we hold a really important, it's very important to us. So thank you. And now time for questions.
Yeah, thank you so much for this presentation. No worries about the time. I think all of it was really, interesting. You guys are already ahead of me. I was just going to say, let's give Caroline a round of applause.
I'm going to get up and turn the light on real quick, so I'll be right back.
Yeah, no worries. So while Caroline's doing this, normally in this kind of a call, we just get people to kind of queue up in the chat. But
All right.
Since there's only 10 people, I'd say, if you've got a question for Caroline, just turn on your video, turn on your mic, maybe let her know who you are. Yeah, I could maybe start. I have just kind of like a meta question. Covanta sounds like an awesome place to work. So I'm just curious about how you kind of learned about the opportunity, how you started making that connection, and how you got there after ISE.
Yeah, so it kind of timing worked out very well. I just happened to be applying for a bunch of different jobs in the spring during my thesis. I actually believe I found the job on Indeed, which kind of sounds crazy because those kind of websites feel like a black hole. They happened to be my boss happened to be looking at my resume right when I had sent it in, so it kind of worked out really well. But I know when I was trying to look for positions, I was utilizing, I think it's called dayawaycareers.com. So that is an emphasis on people that are entry level, looking to get into sustainability in various business. So I was looking there too, but I just happened to be lucky and get the timing right on it.
Cool.
Hi, Caroline. Thanks for the presentation. That was very interesting. My name is Matt. I am a first-year ISE student. And I was wondering, does all the energy for the combustion process come from your waste energy cycle, or is that energy sourced from just a traditional power plant?
Yeah, so the energy, the combustion itself is from the waste on the boiler grates. Obviously, for starting up and shutting down of the boilers, we need to utilize auxiliary fuel. So sometimes there's natural gas just to get the system up and running, in order to make sure that our combustion is thoroughly done. But yeah, we just do the combustion through the waste on the grate.
Oh, sorry. Go ahead, Juliet.
Yep. Thanks, Carolyn. That was really, really interesting. I was wondering, given that there's still so much disposal of waste by landfill in the US, for instance, so there's room for a lot of growth in your industry, right?
Mm-hmm.
And so my question was what's the rate of growth in installing new plant? Is it easy to get all the permits? Is there real interest from municipalities, or
in the
what's
US,
the situation?
not really.
Yeah. Really?
Yeah. So since we have so much room, we have so much land, landfill, sending the trash to the landfill is actually in most areas cheaper than bringing it to our facility. But that's why we have a concentration in the Northeast. So for example, we have, I believe, 4 or 5 facilities in Long Island on New York. So it's an island, so it would cost more money to send it out to like Pennsylvania or Ohio to truck it up there. And it also has to come down to regulations. Like in Europe, I believe that the reason that it has become so widely used in Europe is due to the rules and regulations set forth by the agencies, whereas there's not really a push here in the US for that. Does that answer your question?
Yeah, it does. So it's kind of seems like after this policy and regulation, and then it's also related to population density.
Mm-hmm.
Like, that's interesting. Okay, thanks. Yeah.
Sounds like you're forming like a thesis project, Juliet.
Oh, I'm just, I have a bit of an affinity for this subject, because the only year that I spent out of geothermal in the last like 25 years was actually working for environmental engineers, working on landfill leachate and tracking landfill leachate. So yeah, so it's kind of interesting. Thanks, Caroline. That was really good.
Yeah.
I have a question. I don't know if my video is on.
Yep,
I'm Tenley. Hi, I'm Tenley. I'm currently a second year student here working on my thesis. So I originally went to Iowa State University in environmental engineering, and the city of Ames, where my university was, actually had a resource recovering plant, which is like almost basically the same thing. And it was kind of interesting that there were a lot of like social problems in the community. A lot of people were kind of frustrated with this process, mainly because they felt like it didn't really encourage, especially like in a college town, it didn't encourage recycling as much, because that's just where all the energy came from. There weren't any like recycling centers in the city. But they found it like just cheaper to have this resource recovery process than to actually implement recycling that would be nearby. But I guess my question is there any like social issues where you're at with this process? Any kind of pushback?
Well, first of all, I want to say that there actually is studies. I have an extra backup slide. Let me see if I can find it, showing that energy from waste actually encourages like as you use energy from waste and recycling, they complement each other. So hold on, let me see if I can find that slide.
This is also a really good thesis tactic if your presentations are too long.
Yeah. Oh, yeah. Always have backup slides for your thesis. Yeah. So this is comparing it. You can see my screen, right? Still? Okay. Yeah. So based on studies in the EU, that as landfilling has decreased and energy from waste is increasing, you can see that recycling rates have also increased. But then again, I think there's more incentive in Europe for recycling. It's not as, I guess it depends on where you live in the US, but it's not as widely strived as being important. One of my coworkers actually said that he went on vacation with his wife a few years ago in Europe and saw there was like 4 different bins, so like for plastic, paper, compost, metals, and he's like, there's no way that these are clean and that like there's no contamination between the different bins. And he opened them, and like I think it's a cultural thing in that regard. Let's see, your question in regard to other like issues related to, sorry, can you say that again, Tenley?
Yeah, no, I was just wondering like if there's any other like social issues. I guess you kind of answered my question, but any just pushback in your area? Because I mean, college students were basically the only ones that kind of cared about the recycling in the area. From when we were talking with the plant and everything, they're the only ones that were really pushing for more recycling. But yeah, it just wasn't, I don't know, it was just, there was like huge pushback of why it was there, but they were so proud of it.
Yeah. Well, I mean, there has been pushback in the past of energy from waste facilities, especially in the US. A lot of our facilities, unfortunately, are located in like lower income neighborhoods just because they're like more densely populated. So that's why we really hone in on having our community outreach and being a good neighbor and just kind of educating people about energy from waste now, because I believe there was an amendment to the Clean Air Act in 1990, which really pushed for, let me go to another backup slide. So it's MACT, which is maximum achievable control technology. And this had been implemented starting in the 90s, and you can see that by 2005, that percent reduction had like significantly increased in all these different pollutants. So it's kind of, as regulations came into play, waste energy facilities had to improve their air pollution control and their technologies. So it kind of went complementary with it. So I think a lot of people also have pushback of it because they're thinking of, like, we like to call them your grandfather's incinerator. So like back in the day, trash just used to be burned to just get rid of the waste. So I really think it's just educating the community and then also participating in the community with different volunteering programs, bringing people into the facilities to see how the technology works, just being very involved. Unfortunately, the last year, we haven't really been able to have facility tours, but we've still done some community engagement, like you can see on the slides. Some of the ones have masks, so you can see, for volunteering and just toy drives. And just like I said before, it's about being like a well-rounded business as well. So we are producing energy and reducing waste, but we're also being good neighbors and being involved in the communities. So that's kind of how we try to help with the pushback from the communities, just through education and community involvement.
Awesome, thank you.
Mm-hmm. Any other questions?
I actually wanted to build off of Tenley's question because I thought it was a really good one. Can you talk about how, like, the efficiency of this waste to energy and like the level of recycling programs that participate in it? Like, is it better or more efficient if the waste is sorted beforehand, or does that really matter to you?
Yeah, so like I said at the beginning, we're proponents of the waste management hierarchy. We want to start from the top and go to the bottom. Even though our industry is energy recovery, we want to make sure that we're preventing use as much as possible, reducing recycling, composting, and then energy recovery. We actually don't like plastics in our stream because they have a high BTU. So our main service is waste management. So we want to take in more waste because that's where we get our money from the tipping floor fee. So if we have too much plastics in our waste, we can't process as much waste through our boilers, which means obviously we make less money too, but we also don't want to combust the plastics because it's not good for the environment. But yeah, so the trash has the BTU ranges a lot. Let's see. I have another slide here. But yeah, so it's very variable. And so the heating value ranges, but we do not want plastics or anything in there.
So kind of the community engagement goes hand in hand with, like, even just your operations as well. Cool. Thank you. Is there anybody else that has a question for?
Yeah, I have another question. When you mentioned the cost of bringing waste to a landfill is usually lower than bringing it to one of your plants, is that primarily just due to the proximity of landfills to where that waste is coming from, or is it something completely different?
It's mostly due to the regulations. So since there's not like a carbon tax or some sort of environmental tax on landfilling, it's super cheap because there's a supplemental amount of land in the United States. So if it depends, you have to depend on the different factors, like how far the trucks are driving in order to bring the garbage through the landfills. But that's why we were saying we have a lot of facilities in densely populated areas because it's just easier to bring it to the facilities. And also, yeah, it depends on the rules and regulations. So like New York has a lot more environmental regulations than other places in the middle of the country. So that's another factor. It's very dependent upon regulatory.
Okay, and so when you are siting a plant in a densely populated area, do you face any pushback from like residents who don't really want to have to like look at the plant, or a lot of people typically don't want to live next to any kind of really industrial plant.
Yeah.
But I've been interested in like this the Amager Bach plant in Copenhagen. I'm not sure if you're familiar, but they incorporated like a ski slope and like a green park onto the top of it to kind of make it more, I guess, appealing to residents.
Yeah.
I thought that was a pretty interesting way to incorporate a plant like this into an urban area where people might get extra benefits from the plant.
Yeah, no, yeah, there's definitely a pushback from people in those communities, and so unfortunately, we've acquired most of our facilities. So we bought them from we haven't, I don't believe, I could be wrong, but I don't believe we've built any facilities in the US. We've built one in Canada, in Durham, York. That was in like 2015 around, I believe. And then we're helping with the one in Ireland in the UK. So we haven't really built any facilities. They're kind of just like where they're located. And of course, some of the facilities are located in more urban, densely populated areas. And so they like to blame the facility with the stack on the pollution, but there's obviously a bunch of other industries in the area as well. There's a lot of cars and transportation. We actually have on our, I was supposed to say that, so forgot. Under my name, there's a link to our Covanta sustainability report. So there's a lot of information in there. And within there, we have actually breakdowns of each of our plants and the emissions, the different types of emissions. So for example, NOx or SO2 or particulates in comparison to other industries in the area. So we utilize that when we're talking with the community and community engagement, because it's really easy to just blame one of our facilities with a stack, whereas actually a lot of pollution is coming from the cars. But sorry, I'm going off a little bit on a tangent, but we also have facilities that are operating in non-urban or not as many like lower income urban areas. So for example, a bunch of residential areas on our Long Island facilities, the facility was built and then they built the residences around it. And I really just think it's the community, the area in the more urban like areas, they give the pushback because they're exposed to other areas of emissions. But it also comes down to the education as well, because in Europe there's not that many landfills, so a lot of people have these energy from waste facilities in their backyards. So it's just it's a different mindset in the US. So that's why we have to continue education and outreach programs and tell them what we actually do rather than what they read. Hope that answers.
I kind of wanted to build on that question and kind of what Juliet was asking as well. When I saw the statistics for Canada, I was like, oh goodness me, that's not very good. So how could, I mean, in your opinion, or perhaps, if Covanta has an opinion on this, how could countries like Canada or the US, I guess, grow or make the business case more competitive to like just shipping to landfill?
Yeah, so that really goes hand in hand with the rules and regulations and the tipping fees. We'd need to, well, in my opinion, we'd need to have the regulation, have more of an emphasis on the regulatory side, so that it would push to have these facilities be built and be constructed. Also raising the landfill fee so that it makes it more competitive with energy from waste. So it's kind of difficult since it is so cheap in many areas of the country. And I'm sure Canada's in the same boat.
So then I mean, we have a lot of land. Yeah. So I was going to ask, so then is Covanta, I guess, like actively lobbying for these policies to be made or
I'm not
changed?
sure, so I don't want to answer wrong, but I know right now
Yeah.
it takes such a long time for all this to be enacted. Right now, our focus as a company is to continually improve the facilities that we are operating in the U.S., as well as to help with the UK expansion, since there is already policies in place that are attractive for energy from waste. So hopefully in the future we can build more plants and more facilities, but our focus is on maintaining our current facilities and helping those overseas.
Okay, cool.
Anybody else?
I did notice that we also have Ragna on the call, and I know the technologies are different, but I wanted to just see if there was a conversation there about like carbon scrubbing technologies, and maybe there's an overlap that can happen there.
It's probably possible in some way. We're always looking for like other industries, for sure.
And then you can use the CO2 sequestration and pump it back into the ground. If you build if you build a plant there, yeah.
Exactly.
Yeah, I just wanted to emphasize that. I think when most people think about sustainability, they don't really think about waste management. I mean, I didn't really know about energy from waste until I started working here. So obviously we're fighting to reduce our emissions and our impact on the environment and climate change, but it's important to look at it holistically and know that there are actually other areas to look at as well, because landfills have a lot of methane emissions, so if we're still emitting methane from there, I don't know. We need to improve that there in order for combating climate change as well. So it's something to think about.
Well, I mean, I think you're talking to the right crowd for sure, and I think it's awesome that we have you coming back and talking to our students, and just like you said, you weren't very aware of it, but now hopefully this class and anybody who watches the YouTube video afterwards can kind of get an introduction to this.
For sure. I think it's neat.
So if nobody else has any other questions, Caroline, if anybody's interested after they see this video, can they reach out to you?
Yeah, for sure. And then I also like I said before, I highly recommend under my name in the presentation, we have a sustainability report, and there's a lot of goodies in there. So if there's specific questions that I can't answer, I feel like the report kind of does a really good summary of the company. And I think we're trying to put out one every year, so there should be one out in the fall as well. But it's a really good resource. And there's a lot of good YouTube videos too. I know before my interview here, I literally watched like 15 different videos.
Before we end this call, let's just give Caroline one more round of applause.
Thanks, guys.
Thank you so much for joining us.
Yeah, thanks for having me.
That's super interesting.
Thanks.